I'm halfway solving this problem. I think. You get all the prime numbers till 10,000 and based on the whether the current number is prime or not, you do some shenanigans. Otherwise, you directly get the chance. So now the idea is that n stop is equal to like prime index and I need to send an intent. And this and this. And this. And the other n is equal to have an n. So for int I equals to n minus n, I greater than equal to prime that is start I minus minus. Okay. Oh, I never added the error minus. Hmm. Minus. Minus. All the time. If nums of I, I'm sending the prime index, I should send the prime number as well. That if this modulo is modulo is equal to I index, this itself is a prime number, prime index equal to 0. What am I going to do? I'm going to say that num of 0 is going to be this particular index. This particular index, it's going to be this I. Which is just plus 1 and return whatever the current I is. Otherwise, simply return start, I guess. Maybe this should be super expected what? And so the group is open. So pressing. Cannot find the symbol n plus 1. Can I try 25? Division by zero. There's something wrong with the jump order. Okay, if this is a prime number, you try to find the next prime number. Hmm. If I get a number,
कौन से कार्य चल रहा है?
नीचे रखा है झोले में, राइट साइड में, जो सेकंड राइट साइड में, हाँ उसमें. If you are not a prime number, means I have to jump. So I will jump. If you are not a prime number, I have to jump. Like it's simple. If you are not a prime, jump somewhere. You just jump somewhere. If you're not a prime number, you jump somewhere. It's just about with this. So that is just plus minus of 1. And then you check. The thing is that this is completely unnecessary. Infinite loop, yeah, because I is not getting updated, I is equal to I plus 1. I'm assuming I'm on this one jumping to the right. this operation not happening? Okay, I'm not calculating the minimum jump at every index. I have to make a decision. Don't care about this. At every index, I have to make a decision. But then it would be a big offense here. Use BFF, BFF, BFS, BFS to work. I need to use a BFS. That does not help. Go. What's the search? A queue. What am I adding in the queue? Shortest path. I can calculate the shortest path. Decompute prime factors and build a bucket mapping each via sieve. I've already done that. And build a bucket of prime, mapping each prime number to all indices J. Build a bucket. So just make a hash map. Decompute the prime factors. No, this is not straightforward. During the BFS, when an index I and Q its edges and steps I and all indices in bucket Q for each prime divided nums of I. So 11 into 3 is a prime. No, it's not a prime number. Okay, let's try to do this first. Remove this. Um, hmm, so it's like every prime number that divides nums of I gets added. So if I have a key value pair, a key value pair, what am I storing here? For every nums of I should have all the primes. So create a hash map, a map of integers and integers. No, I don't want a map of integers. I want a map of list of integers. Map is equal to new hash map, blah blah. Then I start traversing for int I equals to 0, I less than I plus plus, int current is equal to nums of I. Nums of I if this time current we don't do anything. If you are a prime number, then well, something will happen. Else, okay, now how do I add? I just have another for loop. That's the fucking stupid. Prime number, you can just map dot put for current arrays dot as list and you can do that prime does that new array list. Yes, now I have to start computing. Then I have to start computing. How do I compute? I have to run a loop. So then you know, I create a list, array list for int I equals to 0, I less than integer of 1 unique 5 plus 2 I plus plus if this current modulo if this prime of this I and this current number modulo this equal to 0. Just going to attempt dot add this particular I. And after the loop, I will say math dot put for this current new array list. I think this will work. What if I have to add an existing list? Okay, I can directly put this. That makes sense. Use a BFS. Which means just use a BFS. Create a queue of integer. Public boolean is valid. We'll get them and int I minus one. So like in previous, in next, in next, if next uh, it's greater than equal to n, or previous is less than 0, return false. Otherwise, you can just return true. So while this queue dot not is empty, and top equals to q.poll, if is valid, if the like if is valid and population, if this is valid, you add it to the queue. Not really actually. Don't do that right now. Okay, this just got a lot more complicated than I was expecting it to. During the BFS, when at an index I to the and cube its ages and steps. So the next one and the previous one. And all the indices in bucket of P. What is the bucket of P? It is the mapping. So you're creating a set. Then what? How do I dump a list into a set? Should just create a set and then add everything. So create set, set of integers. Like I said, prime indices or add or notice the rest. Top dot map dot get top. All right. But what am I even adding this? So you find all the prime factors and then you find all the numbers that those prime factors also divide in the future. Fudge. Store their indices, that's a different problem. So I get a map of prime map, hash map. So I have all the prime factors of a number. Do I have this? Get prime factors of each number. Find all the numbers that are divisible from all the primes, I guess. Create a list as well. I need this one. I can do one stupid thing. I can create a list of integers, algorithm, prime, encountered, new array list. If it is visible, I can create a set actually. Set is better. set of integers, hatch set, times encountered, and then simply say primes. This should be that's primes encountered dot add the current this and times encounter dot add or just add I have a hash mark that is prime map. So for int I equals to 0, I less than primes and counter dot size I plus plus. Now I have to do a loop. That would be int top is equal to, how do you add in more elements on a set? How do you elements from this set? No, I'm thinking there's no point. Just make it a list again. Seems embarrassing, doesn't it? If not contains C, there is this times and counter dot get I. If you do not exist, I have to create a list of features, call it temporary and array list. We call it a new array list. The time output is just there's nothing to continue, doesn't matter. Now what I need a function to get all the uh, divisible all the divisible numbers indices. So some function get divisible with I will send you the term for current prime number. I will send you the list. And I will send you notes. Okay, fine to public void It's going to get a prime. It's going to get a list of integers divisible, and it is going to get the nums. Maybe the index for I equals to 0, I less than nums dot length I plus plus. If nums of I, namely the current prime number, equal to 0, listed dot add this number. Sure. Now I have, so now I have this. Okay, now we come to the problem. During the BFS when at index I, you enqueue the I and all the index adjacent steps I plus one and I minus one, and all the indices in the buckets. We want the indices, not so this gives me all the prime factors of dot in a set. I iterate or would have to add this as well. If is valid, what is the top plus one, I enqueue that is list q dot add top plus one, and then similarly, just if it is valid, I can copy and paste this for top minus one as well. We add those to the list or to the queue. I have the prime factors of the top number in this set. Then for each prime number p, dividing nums of I. Okay, I have it. All the indices. So I need to get the map of primes and the primes from the set and add the indices. The hell I'm going to do next. Indices dot size I plus plus. And after the system, you have to be a prime indices dot clear. I don't know how useful that was. Q dot add. I forgot how set works. How to access the elements. In a set in Java. Oversystem for an integrator in Prime indices. This q.add this iterator. But then what? Do I need a priority queue? I'm not even counting the maps right now. Do I have all the indices, whatever the fuck it is? If I have those, if I have all the indices that this particular non-prime number, not non-prime number, hmm, I think I'm on the verge of giving up. Now this is another issue. I cannot directly add it. It's all in a list. Now I need an iterator for a map of dot entry in integer from a list of integer. Actually, no, I just need one integer inside of prime p.get iterator. And I have to add everything in the user q.add inside index in this. I have to add the index. I don't even know whether this compiles or not. Infinite loop. Where is this? 53, 50. So line 27, it's not this. It is this. Makes sense. So you go to line 39. I've already, let's just make this J, make this J, make this J, just add the G, that's it. Line 54. division by 0. Then I'm even dividing by 0. Line 40. J is not, J is greater than 1. Ah, what have I done? Oh, wait, what? My code does not even compile. That is the stupidest thing. Whoa, 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 whoa. Alt Shift F. Okay. Alt Shift F. Somehow worked. Can I at least? I'm so tired now. I have no idea what I'm doing. Okay. Check online. Check the solution and intuition of LeetCode 36293629 and explain it to me and fix and then what I'm doing wrong besides not calculating the jump in the jump. Oh my god. Sure. Okay. You already recognize Artika. I have to had to use hints. The actual teleport rule. What the problem really says. From an index I can go to I minus 1 and I plus 1. If the current terms of I is a prime, then I can jump to any index j provided that nums of j modulo that prime number is 0. So the element at the jth index is divisible by the prime number. So every node is an index. Edges are the valid moves. Every edge cost is 1. So all of you are like, so for this is a valid move, and then I straight up jump to 6. So like this, and then this. Number of edges, like moves minus 1. You do not want to pre-compute all edges explicitly because edges can become huge. We create prime list of indices divisible by the prime number. Hmm. Now during DFS, I'm at index 1 and nums of 1 is equal to 3. Uh-huh. I instantly get access to all the indices that can lead me to that number. Okay, I'm adding, नहीं, I'm adding I. Okay, what's the problem? The map of integer map. I'm doing something wrong over here. Can you shut up? I. We fix that. Horribly expensive factorization. Hey, Bhagwan. Okay, that makes sense. I'm going to 10,000 for every single compute. Let's just remove everything. Smallest prime factor instead of checking. Dude, what? M of log M. What is even happening? Okay, let's start from here. Get the length of the array. Sure. Get the length of the array, and if n is equal to 1, you just return a 0. I mean, yeah, if there's only one element in the array, makes no sense. I don't think there is one element in the array. I mean, there can be a minimum of one element in the array, whatever. Then you build the C prime factorization, the prime table, so the max value is equal to 0 for int x in nums. Why do you need the maximum? Or you calculate the maximum value? I see. Maximum of max value and x. Then you build this p max value. Let's start working on the. I think I should just copy the code. I should just copy this version. Just copy and paste. This builds the C of Aristo something array. Okay, now I start making the prime array. Integer of list of integers. Prime map is equal to name hash map. I will store all the indices. I will store all the prime numbers that are in the array and also what numbers are divisible by them. Not the numbers that are divisible by them. The indices of all the numbers that are divisible by those prime numbers. Okay, so you fill this with factors is equal to prime get pf of nums of I for int prime in factors. Get the factors. You get a list. The first. I have no idea what is this. Prime map dot compute if absent. Compute what? Compute prime. compute prime k2 array list dot something dot add uh, so what is this doing? This is doing something. Computing what? Prime map dot compute if absent, like add if absent. I don't know. Let's build the prime get prime factors method function. Get pf. So public list integer get prime factors and you get a number. You create a list of factors that is going to be implementing a new array list. Like array list is going to be implementing the list interface. Well, the number is greater than not exclamation mark number is greater than one. You say int prime equal to SPF of num factor boy what factors dot add prime. Huh? Oh, because I'm working on directly on the number. So if num modulo of prime equal to zero. Uh, it's a num divided by you just you divide that number by num by that prime number. So I have a prime SPF of num. What is SPF storing? SPF is storing the indices. I have no idea. What is this as well? Just return factors. Okay, there are a lot of confusions in this code. Just like the previous, like the question I saw yesterday. It's not as straightforward as I thought it was going to be. Okay, now you create a queue of integers, which is hmm, it's Boolean, visited, new Boolean of size n, and I add zero, okay, I add zero, and then I set visited of zero is equal to two, and int jumps is equal to zero. While this queue is empty, not empty, I get the size of the queue and I add randoms. Oh, whilst I'll keep decrementing the size, and as long as size is greater than zero, I will get the current from the top of the queue in front of the queue. If current is equal to n minus one, so it's storing the indexes, which is going to return the jumps. Otherwise, if current minus one is greater than equal to zero, and I haven't visited this current minus one, I will mark it as visited is equal to true, and I will add it to the queue. You check the left index, and then you come to the right index. is less than n minus it's less than n rather. And then oops, I haven't visited this current plus one. I set this to current plus one is equal to two and I go q dot offer current plus one. Teleport only if nums of current is a prime. Okay, so the current index makes sense. So if nums of current is greater than one and smallest prime factor of nums of current. So the current number basically is equal to nums of current means you are a prime number. So int prime equal to nums of current. If okay now see let's if in the prime map I have this prime number, I need to get in the array list and I have to check now if I have it. Okay, wait, what? I go to all the indexes that are divisible by that prime number. So if I haven't visited this, I just named it index. Okay, I will just mark this index as true and then I will offer this as well. I have to remove it. Prime map dot remove this prime number. Oh, because I have already visited this. I honestly don't know. Still don't know what is going on here. Missing error state. What? Missing something. The fuck? What? This is closed. Okay, did I do something wrong? Why is everything okay? Everything is minus one. That is interesting. Am I implementing jumps incorrectly? Are the jumps incorrect? Should they be? Hmm. What? 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 How do I even start checking this code now? These conditions are wrong. Oh, my bad. I have no idea what is going on here. So you time index is nothing. Also, it's like if get or default or just add something, computer is absent. Or if two doesn't exist in this map, you just create a new empty list and then you add all the elements into it. Oh, makes sense. That makes sense. What is SPF? SPF is storing the smallest prime factor. What is build SPF doing? And what else? You store all the numbers and then you visit. This jumps only if it's a prime number. Why and how is this different? It may be size thing. Explain. For every number x, store the smallest prime that divides x. That divides x. Smallest prime number that divides x. 5 is 5 or 6, 7, and then 8, and then 9, and then 10. So SPF array becomes. So for each number, what is the smallest number that divides it? Divides it. Okay. Okay. Hmm. Every number is its own smallest prime factor, right? So prime factor. And then we start calculating the processes. For 10, if it is already a prime number, mark all multiples of it up until the maximum value. And you jump I times because 2, yeah, like after 2. Okay, so it's basically the table of 2 now, or table of 3, or table of 5 or 7. If 2 is a prime number, then 4 is a prime number, then 4 plus 2 is a prime number, 6 plus 2 is a prime number. It's not a prime number, it's divisible by 2. Similarly, if 3 is a prime number, 3 into 2 is a prime number, 3 into 3 is divisible by 3. That is the logic. So SPF of 4 is equal to 2. You're setting all of those values. Whereas that you store all those numbers as J. Okay. And you do that for all the numbers. I see. Okay, and now what is happening in the queue? So I calculate all the small for every index in the SPF array. I calculate the smallest prime number, prime factor of that particular index, and that index is representing a number at the end of the day. So if I have an array, I can just figure out the smallest prime numbers. That makes sense. And that gives me big O of 1, like constant time to check whether what is the smallest prime factor of a particular number up until the maximum value that is. Okay, and then I can store What do I have to show? Then I have to take all the prime numbers from I have to take all the prime numbers from the array. I have to get all the prime numbers, get all the prime factors of each number in the array, and then store it in the hash map. Then I create a visited array, and then I create a queue for the BFS traversal, and then I add the starting element, which is the starting indexes, which is zero. It's like I start from zero and I mark zero as true. I get the jump counter. Okay. Then what is happening inside the queue? Inside the queue, the graph is index equal to node. Every index is a node, not values. Okay, so 0, 1, 2, 3, 0 is 2, 1 is 4, blah blah blah. Next, what are the possible moves from index I? If it is not a prime number, if the number at that index I is not a prime number, I can either go a plus one, I can go a minus one from that particular index, provided they are valid indexes. Teleport move. Only if the number at that index is a prime number, then I can jump to all the indices that are divisible by that prime number. Okay, you build the prime map, take this array, take this integer, take the array, build the prime numbers, build the prime map. So storing all this is done in the first loop, the top function which is build SPF. So every number gets the smallest prime number. No, wait, what? Okay, for every number I get the prime number. ठीक है. उसके बाद what happens next? All the numbers that are divisible by 2, all the numbers that are divisible by 3, and all the indices that are divisible by 2, 3, and 7. There are three prime numbers in the array. There's no 3 in the array. Or 6 can be written as 3 into 2, so like, but you should have taken 2, but I don't know. Works, I guess. It's stored in the index. Standing at index 0, BFS level 1, 0, jumps for current top, you get the top. That is invalid. That is valid. Unvisited, you add, you mark it. So SPF of the number at that index is 2, which gives all indexes is equal to. I think I kind of know what is happening. I mark everything. I get the top element, the first, like whatever the first element that entered the queue is. I mark all the indexes that I can visit from it. So I plus one I can offer an add into the queue as well. And over here, if the current number is greater than 1, if the current number at this particular index, the current index is greater than 1, and the smallest prime factor of this current number is equal to this number itself, means it is a prime number. This is a prime number if this is a prime number. No. If this is a prime number, i.e. I dot e comma the top is a prime number. You find you find okay, there's a key for this prime number. If I have all the number indexes that are physically visible, you add all of those. When am I even exiting this inner while loop? The condition is while size is greater than 0. Here the condition is whatever is the size of the queue. Because I'm because this works level by level. Works for each level. Actually, that makes sense. Not immediate, every level that is reachable by the current node uh, index from the, and that's it, the current index. The every index that is reachable. You work as long as that. Okay. Makes sense, makes sense. What is happening is basically you find all the prime numbers, then you find prime numbers, you find all the smallest prime factors of each number up until the maximum value in the array. You find all the prime numbers, and then what? Find all the numbers while on the indices where the number of that index is modulo equal to 0 from that prime number. ठीक है? Then you process each index based on the number, on the nums of that index. You check what am I doing? You in the while loop, size gives me the current nodes at this level, reachable from this level. This while size minus minus If the nodes are valid, which are the indexes are valid, check the visited and add them accordingly. If and top equal to q.poll, and this is also an index. And if the nums of that index equal to a prime number, in that case, gives me a prime number. The top index gives me a prime number. I will, if it is not a prime number, I will only add and check the right and left nodes. If it is a prime number, then I can jump. You add all the indices reachable from that prime number index. And here you can increase jumps since each level is being computed. That's a fancy word. The idea is that I have not visited up until for this if not visited, add them and compute them for the next level. Otherwise, I can ignore them. If if nums of index or nums of top is not a prime number, I can I can do what? I can just increase the point is that if this is not a prime number, I cannot jump the index. I cannot randomly jump. I need either +1 or -1. So like top -1 and top +1. How long is this? Hmm, fine. If it is a prime number and add only the top +1 and top -1. If it is a prime number, you can jump to indices that are not top +1, that may not be top +1 and top -1. So for a prime makes sense. And if I say that hey, this top is equal to I just break. If top is equal to the last index, I just return jumps because I figured it out. So I think I have a pretty clear idea about how this is working. Now this works. I can save this. Never actually use this. Hmm, what is this? Mm, mm, mm. No, thank you. This works. I should look submit it as well once again. Cool. Nice. This was a nice problem. Nice problem. Yeah. It was graph, it was BFS, it used hash maps, it used this prime calculation function, sieve of something something. I forgot the name. You can get all the prime numbers up to a particular value of n pre-computed. So in this function, I get the smallest prime factors of all the numbers up until max value. Here I can get all the numbers in log of in constant time. Can I get it in constant time? No, I can get that in constant time almost. Not constant, but near about constant. Actually, no, what would be the time complexity of this? Get a number, get another number. The largest number can be five. So it's like log of something. Yeah, it's this log of something. Not log of n, but log of nums, I think. What is the DC of this? Log of n, yep. Log of nums. Base for a single number now. Hmm. This calculates the minimum jump. So I get the maximum value. Over here, I get the maximum value. Then I build the smallest prime factor array. Then I compute all the prime numbers that are in this. I get the smallest prime numbers, prime factors of all the numbers in the array. Then I start my DFS, BFS traversal, BFS traversal, not DFS, BFS traversal. And I do all this stuff.